Today we are going to look at this amplifier board. This is the Accuphase E210 modified version L6 by LJM. The power supply for this board can take dual 25 volts up to dual 55 volts. So this board has a built-in preamp. So the gain of the preamp is 100, and if the preamp is off is 17.5. So we're going to test this board using the preamp on the on position. So the jumper is set to 1 to 2. Let's see what is now 1 to 2. So 1 2. So preamp is off. See, jumper 1 2, preamp off. So let's look at the jumper. Okay, so the jumper is on pin 1 and 2, so the preamp is off. So let's look at the dimension of the board. It's 82 mm on this side and around 76 mm on this side. We have 2 filter capacitors here. It's on one on its negative and positive rail. So this is 63 volts, 400 UF. Let's look at the power transistor. So that is C5200 and A1943. So I already have the board hooked up to our test beds here. We also have a fan here blowing directly to the heatsink. Okay, this is our power supply. It's already set to dual 55 volts. So first we're going to do 4 ohms test. Dual 55 volts power supply. Maximum power output RMS 1% THD, and we're going to check the maximum power output of the amp with the least minimum distortion. Same with 8 ohms. Currently we have our dummy load is 4 ohms. The 4 ohms dummy load is hooked up, so we're going to start with this one. So our THD meter is already set to 1%. So we want full scale here on the meter. Okay, so that is 1%. And that is our output, 93.6 volts peak to peak, 1% THD, 93. Now we're going to check the output of the amp with the least minimum distortion. Okay, so we're going to set this to 0.1%. Okay, so that is the maximum power output of the amp with the least minimum distortion. That is 0.1%, so that is about 0.02%. And the output is around 90.4 volts peak to peak. So we're going to do this now, 8 ohms. I'll be back after I swap this with the 8 ohms dummy load. Okay, so I'll just show this one, the current consumption of the amplifier from the power supply. So as you can see here, the amplifier is pulling. It can reach to around 200 watts on its rail here, so that's about 400 watts. So this power supply can really pull too much current. So this is our dummy load, 8 ohms dummy load. So we're ready to do the 8 ohms test now. I'm going to turn on the power supply. Okay, so 1% HD. 1%. Okay, so that is 1% HD. And our output is 98.4 volts peak to peak. So now we're going to check the output of the amp with the least minimum distortion. So let's set this to 0.1. So that is the maximum power output of the amp with the least minimum distortion. So that is 0.1, full range is 0.1, so that is about 0.012%. The cable D. So that is 0.012%. The output is 92.8 volts. Okay, so let's compute the power output of the amp. So this is 98.4 divide 2.828 inverse squared. Oh, what's happening with the calculator? Okay, so let's do that again. 98.4 divide 2.828 squared divide by 8, so around 151 watts RMS at 1% HD. Now let's check this one. 92.8 divide 2.828 squared divide by 8, around 134, 135 watts, so 134.6, round up to 135. So this is 135 watts. This is in RMS. Now we're going to check the result for 4 ohms. 93.6 divide 2.828 squared divide by 4. Wow, so this amp can do 274 watts RMS at 4 ohms load, 1% HD. 274 watts. And now let's look at the output of the amp at 0.02% HD. 90.4 divide 2.828 squared cos divide by 4. So that is 255 watts RMS. 255 watts. Okay, so this is the results. At 4 ohms load, the amp can do 274 watts RMS at 1% HD and 0.02% HD at 255 watts RMS, and 8 ohms 1% HD 151 watts RMS and at 0.012% 135 watts RMS. So this amp, so looks like this amp is pretty nice. Looks like I will be using this amp. I will be replacing my LJM MX50 with this one. Okay, so thank you for watching. See you next time.